In this video, we're going to talk about functions and their second or third derivatives, any higher order derivative beyond the first derivative. So, if we are given a function, f of x, that we can take the derivative of, and we would find f prime of x, well, we can take the second derivative, which would be the derivative of the derivative, and we might indicate that as f double prime of x. Another way we could think about that, if we consider that the derivative of y with respect to x, well, d dx, taking the derivative of the derivative, that gives me, the way we notate it here, is d2y over dx2. All right, so this is just another way of saying, hey, the derivative of the derivative. And we can do this, further. We can go, we could have the third derivative, or we could have even the fourth derivative or the nth derivative. So this is just, I'm explaining to you notation of different ways that we can write the derivative. I will most likely, in my notes, I would use double prime, or we use this notation, which, if you think about that, we've got 2d, then a y, and then dx squared. So it kind of makes sense. All right, so let's do an example finding the first few derivatives of a function. Here I have a function, y equals 6x to the fifth minus x cubed plus x squared minus 2x plus 8. And let's find the first few derivatives. So my first derivative, y prime, that would be 30x to the fourth minus 3x squared plus 2x minus 2. That represents my first derivative, f prime of x, or y prime, or even dy dx. So my second derivative, the derivative of y with respect to x, y double prime, that might be 120 x cubed minus 6x plus 2. At this point, I could take the third derivative. That would be 360 x squared minus 6. I could find my fourth derivative. I can just write a 4 up there. You can put parentheses around it or not. That would be 720x. And my fifth derivative would equal 720, a constant. Anything after this, y to the sixth, would equal 0. The sixth derivative would equal 0. The seventh derivative would equal 0. The eighth derivative would equal 0. Right? So it's infinitely differentiable, but we can only find values up through the fifth derivative of this function. So let's look at just one other example. Say I have the function f of x equals x plus 2 over x minus 5. And I asked you to find the second derivative. Well, f prime of x would equal the denominator x minus 5 times the derivative of my numerator, 1, minus my numerator, x plus 2 times the derivative of my denominator, 1. All over the denominator, x minus 5 squared. So, f prime of x, my first derivative, that equals x minus 5 minus x minus 2, that looks messy, over x minus 5 quantity squared. So my x's will cancel, and I am left with -7 over x minus 5 squared. That is my first derivative. So in order to find the second derivative, that would mean taking the derivative of this value we just found. So basically we would apply our quotient rule again. The issue is we have this squared here. And I know I tell you we don't normally multiply this out, but in order for us to take the derivative, because we do not know the chain rule yet, we would need to do that. So my first derivative, f prime of x equals -7 over x squared minus 10x plus 25. So at this point, if I went to find my second derivative, I would have my denominator, x squared minus 10x plus 25, times the derivative of my numerator, which is 0, minus my numerator, -7, times the derivative of my denominator, which is 2x minus 10 plus 0. So 2x minus 10. And all of that would be over that denominator squared, which was x minus 5 squared. So this cancels. I'm left with +7 times 2x minus 10. So that is 14x minus 70 over x minus 5 to the 4th power. And that represents my second derivative. I would like you to note here that when I wrote x minus 5 squared, that's equal to my denominator, and I squared it. Right? So that's how we find the second derivative. It's just taking the derivative of the derivative. And again, moving forward in this unit, we're going to be finding more rules that make our lives easier. But we need to have a firm understanding and good practice with the initial rules before we move ahead. So please make sure you understand these before we start talking about derivatives of trig functions and then also the chain rule.